in the interest of time, let's just get started. Um, if you're still getting food, it's fine. Just get food and come. The first few minutes. Has everyone filled both these forms? Just yeah. If anyone hasn't, please scan it now. We need this to get money for the food. Okay. Um, the the way this workshop is going to be structured, the first sort of 10-15 minutes is just going to be me talking about why we need to use Git at all and what the point of Git and GitHub is. But the majority of this workshop will be like a hands-on demo where I'm going to get you guys to um, work on like a sample repository in Git, and then we'll go through all the different Git commands step by step. Okay, show of hands. How many of you have used Git or GitHub before? Okay, about half the room. And is that, is that like Git, is that through like the GitHub website, or have you used Git on the command line? Just the GitHub desktop? Yeah, stuff like that. Okay. Um, okay. How many of you still when you want to save different versions of your files, like let's say you're writing an essay and you have different drafts of it and you make an edit, how many of you still manually save the files as, I don't know, essay draft, essay final, essay final final, essay actually final? You do? I think the even if you don't say you do, I'm pretty sure you do. So Git essentially was made to avoid just that. It's a form of version control which can help us keep track of our projects. And it does not have to be. It's mostly used for code, but it does not have to be just code. It can be text files or honestly any kind of files. And Git will help you keep track of exactly what changes were made at what point of time and by which person. Um, so okay. What is Git? It's at its very essence, it's a version control system. It looks at all the changes in your file and records all the changes over time to give you a complete history of what, from the time the file was created to its current state. You can find out which line was changed at which time and by whom. It's similar to how you can look at version history in Microsoft Word or Google Docs or something. Um, do all of you have Git installed on your machines? Yes? Does anyone need help installing Git? I can like wait a bit. Okay, if everyone has Git, then that just makes our job a lot easier. Yes, if okay, cool. So yeah, a bit strengths and weaknesses of Git. Uh, Again, like I've been saying, it's Git keeps track of every single edit made to every single file since it was created. So it's very hard to lose files. If let's say you go and change something and your entire website breaks, and you can just Git just lets you immediately go back to the previous checkpoint and be like, hey, okay, this is broken. I want to undo all my edits. Let's just go back to the previous checkpoint. It's good for collaboration because um, Git helps you keep track of um, like different versions of the file at the same time. So I could be working on the file, and someone else could be working on another function in the same file. And Git will make sure that there's no conflicts between both the versions of our files. And when we eventually merge them together, everything still works nicely together. Yeah, history allows you to go back, understand changes, revert stuff, and reproducibility. If you know, if there's some error in your code, or for some reason you want to find out like who touched this file before me, Git gives you a log of all the changes made in the file, so you can track what happened for the file to get to this stage. Weaknesses, of course, it can be a bit complicated to use. I know I'm doing this workshop, but I myself like barely use Git for my own projects because I'm just like, I'll worry about it later. And then initially, like if you're not used to it, it can be a bit complicated. Um, Yeah, all of the other stuff is fine, takes up file space, it's very little. You need to explicitly use it. So while Google Docs and Microsoft Word and stuff just track your changes as you're doing them, Git requires you to manually like save every single checkpoint. And if you don't like manually save that, it does not record it. So it's something you explicitly need to do as opposed to something that's just running in the background. So again, that might make it a bit hard to use. But despite all of this, it's there's a very good reason everyone around the world uses Git, and it just makes coding a whole lot easier and predictable. Um, a lot of you here have used GitHub Desktop. You've used GitHub from the website. How many of you have used Git from the command line or like from terminal? Okay, about like 4 or 5 of you. Um, like this argument sort of applies to any command line versus GUI program. It's with the command line, like GUI is it's really easy to get into. You have these buttons telling you what to do, and for a beginner, it's very easy to understand what's going on. That's not the case with the command line because you need to know all the commands, you need to know the syntax, how to type it for it to actually work. And there's no sort of help or indication as to what you should do next. Um, so in that way, the CLI is very unintuitive, but it's a lot more powerful. The graphic interface doesn't have half the capabilities of what you can do on the command line, and the command line is a lot faster. So in the demo today, we will focus on using Git from the command line, like the most basic commands. And then I'll also show you how you can connect it with VS Code, and then it all integrates very nicely into a like a development workflow. Um, okay. Any questions about why we use Git or GitHub? Or is that part clear? Okay. Oh yeah, also, there's a lot of food back there. So if at any point during this you want to get seconds, feel free. Um, okay. Now, this was all why we use Git. Now I'm going to slightly shift gears into the technicalities of what Git is and how exactly it works. Um, Beyond it just being like a version control system, it's okay. So forget this stuff, but what you essentially need to do is Git creates like a sort of backup. So Git is a software that runs on your local machine, and GitHub is a cloud platform which saves a backup of the code that's on your local machine. Um, so there's there's three main things to keep in mind: push, pull, and commit. And it's not that complicated. Uh, earlier I was talking about the way you save checkpoints in Git, right? Saving checkpoints is called committing. So if at any point you make a change and you want to save your progress, it's called committing your changes. And sort of Git will create a checkpoint at that at it will freeze your entire code base at that point in time. So later, at any point, you can always come back to this commit and see how the code was at this point in time. But this is all still happening on your local machine. What if you want to like collaborate with others? Like let's say your friend has a version of the code on his own machine. Let's say you want to push your code to like some cloud database for safekeeping as a backup. That's when the system of like push and pull comes in. Um, like the name implies, pushing is you push the code from your machine to a cloud service. GitHub is a cloud service. Pulling is pulling whatever code is on the cloud onto your machine. So if I've made some changes, for instance, and I want my friend to get those changes, I would push my changes from my machine to GitHub, and my friend after that would pull the changes from GitHub to his machine. And that's how you can ensure everyone has the same version of the code. at any given time. Um, any questions about push, pull, and commit? Yeah. What's the difference between like code on your local machine and then code from the server? So it's sort of so like even it's sort of like okay. So think of the server as just like another machine where the code is being saved, right? So even in your own machine, like so so the way Git works is in your machine, it basically creates a separate .git folder, and that's where it has all these files with the metadata to keep track of changes and stuff. So there are cases. This is like very rarely used, by the way, but I couldn't find a better diagram. But basically, this is used in the very rare case where the Git program or like the Git folder on your machine might have a different version of the code than let's say you didn't like download it from GitHub or whatever. Let's say you just copied the files from your friend's machine directly to your machine through WhatsApp or AirDrop or something. Then you would like let's say pull from like your local Git version as opposed to pulling from GitHub. But you don't really use that much. It's more of a technicality. Yeah. Any other questions? Yeah, the order is git, add, commit, and then push. I was coming to add, but basically, um, before committing, you need to tell Git that you've made changes and tell it what the changes are. So you do git add, which tells Git to add all the changes to its temporary staging area. Git commit commits all the changes that you've added. So you can, let's say you've made multiple changes across multiple files. You can choose to add only a certain section of the changes and then commit them. And then push, sends the changes to the server. So this is a good way of thinking about it. Um, Git add basically, like think of it as an airplane. Git add adds the passengers to the airplane. The passengers here being the files that you want Git to track. Git commit sort of Git commit like closes the door of the airplane and taxis it to the runway, like as sort of a preparation. At this point, you can't add any more files or do anything. It's just locked in that state. And then Git push is where the airplane takes off and it goes to, the cloud or other database wherever you're storing your stuff. All right. Should we move on? Perfect. Um, yeah, okay. I sort of touched this earlier, but basically, you know, um, this is your machine. You're making some edits. You commit that change. You make more edits. You commit that. Make more edits. Commit that. Um, Same here. This stands for like a combination of pushing and pulling. So you pull from the server and then push back to the server. Your friend again runs the same. So he pulls the latest code from the server and pushes his changes, and he gets all the code, makes his edits, commits them, and then once they're back on the server, you can again pull them from the server and continue working. It's and this does not need to happen like step by step. Like you both can work at the same time too. Um, yeah, it's just a very simple diagram that talks about the workflow. Um, yeah. Um, some stuff that we won't cover is Git ignore, CI/CD pipelines, GitHub issues, etc. This workshop will mostly be focused on like the core functionality of Git. Uh, but I'll give you resources to cover to if you want to like look at that later. Now let's if there are no questions about Git itself, then let's move to the demo. That that is from a while ago. Don't yeah, I've been doing this workshop for a couple of years now, and we haven't changed the meme. Uh, you can scan the QR code, but if you want to open it on your laptops, then it's just github.com/IEEE/git-workshop. Like I'll give you guys some time to open this, and we can. Huh? No, no, don't. I'll get to it. Wait, has everyone opened the GitHub repository? Is there anyone who still is? Okay, perfect. So this is what you should see on your screen. Is everyone on this page? Okay, perfect. Short. Okay, so this repository that I made, everything that I'm going to like sort of take you through now is also explained in a lot of detail in the README. So this takes you step by step through everything we're doing. So if you're falling behind or if you want to go ahead or whatever, just you can follow the README. It has very detailed instructions on everything I'm going to talk about. So um, we are first going to start by, we don't, well, this is like a common public repository, right? That all of you are able to access. But when we sort of make our changes, we don't want to make changes on this repository because then like if 10 different people make the changes on the same repository, it's going to obviously cause a lot of conflicts and issues. And we want to keep this repository safe for even future workshops. Um, so the way we do this is by forking the repository. And essentially what forking does is it makes a copy of this repository in your own account. So whatever changes you make to that repository then stay on your account as opposed to affecting this main repository. So forking is essentially just making a copy. And in fact, how many of you have heard of like open source development? Or like the concept of open source in general. Yeah, okay. This is how any open source development also takes place. You don't work on the libraries directly. You fork the libraries, like make a copy of the repository in your own account, and then work on that copy. That's how open source development works. Okay, so can everyone just click on fork, and this should be fine. Like just make sure it's under your account, and this is very important, but uncheck this option, please. We want to copy all of the branches. The the demo is not going to work if you don't copy all of the branches. So make sure you uncheck copy master branch only and then create the fork. Okay, perfect. And once again, double checking, all of you have Git installed on your computers? Perfect. So what I want you to do is just open terminal now. And we are not going, again, like I said, we're going to work in the command line. So we're not going to download zip files or anything from the website. We're going to do everything in the command line. So, well, for starters, again, this is good coding practice, like as in good practice, but you should like set your git configs to your actual name and email. So whenever you make any contribution, other people know who is making this contribution and they can keep track of it. So we'll just do git config, like you can copy stuff from here into your terminal. So user.name, and in quotes, I'm just going to put Aryen Singhal. You guys can put your own name. And I'll also do the same for my email. Uh, Okay. Um, so now, uh, most of you probably like to get a repository onto your machine, go to this green button over here and then download zip and then extract zip and stuff. We're not going to do any of that. There's a simple command called git clone, which basically, again, like it implies, it clones the code onto your own machine. So so it's git clone and then whatever link is over here. So in my case, it would be git clone and then copy the um, HTTP link that's provided here, replace the put your username in the link. So, and by the way, this is the same link that's over here in the browser, and this is the same link that shows up when you click over here. So you just copy the link from here and go back to your terminal and put that in. And this will clone the repository in whatever folder you're currently on. So make sure you're cloning it in a place that you want to clone it to. And the moment I press enter, you'll see it'll say cloning into Git workshop, enumerating objects, done. And just to show you guys what exactly has happened, if I now go to my users Aryen directory using File Explorer, uh, yeah, you can see, oh shit, Git workshop should be somewhere here. Yeah, you guys can see Git workshop. It's been saved under users Aryen because that is where we cloned it into. And this has all of the files. So this is the same as downloading the zip and extracting it, but you just do it in one line. Um, now that we're over here, you just um, type cd and then git workshop. So what this does is takes you inside the git workshop folder that we just cloned. Um, cd stands for change directory. So you change directory to the git workshop. Um, once you're there, um, yeah. So once you're there, you'll see uh, like, so ls just shows you all the files that are in that folder. So you can see there should be a .git over here. README, Java, some Python code, one text file, and yeah. Uh, okay, copy this command in ls a dot git. One thing when you're copying the commands in, do not copy the dollar sign. That's not going to work. The dollar just indicates that it's supposed to be on your command line. This is not going to work for me because I'm on the Windows, but if you're on a Mac, this command should work for you. But that's not that important. Okay, now let's try making some of our own files and adding them to Git. Um, if you not done, wait, does touch work? Okay, I'll just um, wait. If you're on Alice, okay, alice.txt and bob.txt, just create these two text files however you know how to create them. Or if this is confusing, then simply go to your file explorer, actually, go to this Git workshop folder that we just cloned and create two new text files called alice.txt and uh, bob.txt. And once you've done that, come back to your terminal. Yeah. Now we want to. Now we've created these new files, and we want to, save them to Git somehow. What were those? Does anyone remember the three steps we discussed when it comes to saving anything to Git? There were three commands. Yeah. Add, commit, and push. For now, we're not going to worry about push and pull because we're working entirely locally. Uh, so generally, when you work in like Git or GitHub, you'll do a lot of adds and commits. And then at the end of the day, when you're done with your entire day or session or whatever, then you'll do like one massive push at the very end. So for now, we're just going to focus on add and commit. So we've made these new files, right? But Git does not know that we've made these new files. We need to explicitly tell Git to track these files. And the way to do that is using the add command. So it's just git add and then the names of the files that you just created. So git add alice.txt and bob.txt. If you do that, there won't, Git does not really give you any feedback, but just assume that it's done, right? And now the next step, git commit. So what you do is simply git commit. And this by itself will just commit whatever you've added in the previous step. But, good coding practice, we usually want commitment. We usually, while committing, we also add a message just so anyone who's looking at the log of commits later can tell that what happened in this commit really. Yeah. No, this is all on our local machine. And by adding it, so Git has like a staging area. It's like an internal thing. So you don't get to see it. So it's just to tell Git that in the next step, when we commit, these are the files we want to commit. So Git just internal. So when you say Git add, let's say you made changes across 5 different files. Um, and you only want to commit changes, you only want to commit 2 files to this checkpoint. You don't want to commit everything. You do git add, and then you only specify which files you want to add. And then Git will sort of add them to its internal whatever system it has of tracking. And then when it commits it, it will take those files that it has added, commit them, and then get rid of it. So it's going to check or you think you're adding an external check. Yeah, essentially. Also, like in this case, for instance, we have these files were something we created by ourselves. Like these are like entirely new files. So Git, until this point, Git has not been tracking alice.txt or bob.txt. It does not know about the existence of these two files. So we say git add and then specify these two files. So Git knows that it needs to start tracking these files. And then, yeah, git commit would essentially lock down this checkpoint, but yeah. 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 Um, yeah, so git committing would save the checkpoint, but in general, it is recommended to not just save it, but to save it with a message, just so you can keep track of what each commit is actually doing. So we're just going to do git commit and then -m. This indicates that whatever follows is the commit message. And then in quotes, sorry. Yeah, and then in quotes, you type whatever your commit message is. So I'll just say, I am adding 2 new files. Okay. And it's been committed. You can see I am adding 2 new files, 2 files changed, 0 insertions, 0 deletions, create alice.txt, created bob.txt. So that's your commit with a summary of all the changes. And you know, let's see what happened. Let's say you want to, and this is useful even if you want to, like, in the future, keep, like, look at what has happened to this code base in the past. So what you would do is git log, and sort of this gives you a log of, in this case, one, two, three, four, five of the most recent commits that have been made. So, you know, the latest commit is what we just made on Tuesday, Jan 20th. I'm adding two new files. I did some stuff with the logos. I updated the README, update README, update README. So again, update README is probably not a very useful commit message, because what did I update? Like, what is going on? Because there's three commit messages saying update README. I have no idea which one actually means what. So usually your commit messages should be a slightly more descriptive, but yeah, this is how you keep track of them. If you want to exit out of whatever, just press Q and then it'll bring back the command line prompt. Um, the next one is git show. So git show over here, it gives you a detailed description of what happened in your most recent commit, which in our case was, I am adding two new files. It said, there's a difference in alice.txt, where we added a new file, and there's also a diff when it comes to bob.txt, and here we added new file. There's a bunch of numbers and other words which, eventually as you use Git, you'll understand what they mean. But for now, you can ignore them. Just focus on, like, the name of the file and what we did, that being a new file. Okay. Uh, okay. So now I want you guys to, open the file that you just made, alice.txt, in any text editor of your choice. I'm just going to use Notepad for simplicity. And, you know, um, let's, hey, what's your favorite song? Okay, I'm going to type in, I don't really have one. Okay. And then we save this. And okay, I mean, now I guess this is just one line in a completely blank file, so we know exactly what's going on here. But let's say you have a file with thousands of lines, you've been working on it for like half an hour, and you've made a bunch of changes, and you don't remember exactly where you made the changes. Git gives us a very simple command to find out where we've made the changes, and it's called git diff. Diff here standing for difference. So git diff will give you the difference between the your most recent commit and the current version of your file. So comparing the last checkpoint to what you have right now. So if we do git diff, you can see here, it says there's a difference in alice.txt. It's on line number 0. I don't really have one. And the plus sign here means that we've added this line, which is I don't really have one. Again, very easy to see what's going on. Now, okay. So, uh, sorry. Yeah. Okay. Uh, let's say we want to commit this. Do you guys remember how to go about the commit process? Like, what is the first step we need to do? Git add. Okay, so let's just do that. Git add, and this is a shorthand. If you just do git add dot, it will just add everything. So you don't need to like write out every single file if you don't want to. So just do git add dot, but don't commit it because we're gonna do something else right now. Let's say you've added this to Git to the staging area, but at this point you decide, hey, shit, I made a mistake. I don't actually want to commit it. There's still time to undo the changes. So if let's say you do git status here, you'll see changes to be committed, modified alice.txt. So this is in the staging area. And to back out of the staging area, we have a command called git reset head alice.txt. Let's just copy that in. I'll explain each part. Git is just git reset. So head over here is head refers to your most recent commit. Um, Head just stands for your most recent commit as the TXT. So what you're basically telling Git is reset my code base to whatever head was, and specifically do this only for alice.txt. So it will restore alice.txt to the latest version that was saved in its previous checkpoint, and like basically overwrite any changes you've made after that checkpoint. So if we just do git reset head alice.txt, you can see that it unstaged all the changes. And if we go back to this one, yeah, it unstaged all the changes. So now you can do further edits before making any commits. Um, and then if we run git status again, you'll see that it went from changes to be commit, it went from changes not staged for commit, and this is in red because we've modified it but not added it. Um, that's that's this. Okay, moving to the next most important topic when it comes to, and I'll rush a bit because it's 4:45 already, but moving to the next most important topic when it comes to Git, and that is branches. Um, Branches is what really makes Git differ from most other simplistic version control software you guys might have used. And this is like one of the most powerful parts of Git. Branches lets you, work on different versions of the file at the same time, and each branch is essentially an isolated snapshot of the repository. So I can work on one branch, and my friend can be making changes in another branch, and we both can be making changes to the same thing without affecting each other. And then later, at a future date, we can figure out how to merge the two branches together. But branches basically, it essentially creates a duplicate of your code base. And yeah, so um, again, so to just to get started working with branches, it's very simple. Just type git branch, and it'll tell you all the branches that you have. You should see. Oh, yeah, it does. Wait, how many branches do you guys see when you type git branch? Just one. Just one. Huh. It should have. Did not get the other branches. Okay. Um, okay. Oh, yeah, okay. Sorry. When you clone it, it just clones the current branch, but the rest of your branches, if you go back to the repository, the rest of your branches should be here on the repository. We will we'll have to pull them manually later. My bad. Yeah, so you should just see one branch. Now let's say you want to leave master as it is. Like let's say master is running on production code, whatever. You want to test out some changes without affecting the actual production user facing code. We can create our own branch. So let's just do git branch. Um, Sorry, checkout. Git checkout. Checkout is how you can switch between branches. So you just do git checkout. B indicates you're creating a branch, and then you give your branch a name. So experiment one, switch to a new branch. If we now do git branch, you'll see master and experiment one, and the sort of green asterisk indicates that we're currently on the exp1 branch. Um, um, yeah, and again, if you want to switch between branches, you just do git checkout master, and then you'll now be on the master branch. And we can go back to git checkout exp1 so that we've switched to the exp1 branch. Um, okay, Now, let's say let's say we make some changes to the exp1 branch. I'm just going to go back to this thing. I'm going to make a new file called test1.txt. Let's say we add some content to this. Now, uh, remember the diff command we spoke about earlier? We can also use that to check for differences between branches. So if let's say I do git diff master, it tells me about, uh, oh wait, sorry, I forgot to add and commit it. So I just git add and then git commit experiment. And then now if I do git diff master, it, you know, so master has this thing called I don't really have one, and we have this thing called some content. So it just tells you the differences between the two branches. Um, now, okay, so uh, let's say we switch back to our. So this is actually really cool because you can see it happening even in your actual file explorer. So we made a new 1 minute. We made a new test file, right? We made a new test file in the exp1 branch. Now, what happens if we switch back to git checkout master? It's gone because this file was made in the exp1 branch, so it stays in the exp1 branch. This is how you can use branches to like make different versions of your code base, like do some tests, do experiments without affecting another branch. Yes. Because when this is comparing branches, it compares. So if I would get this master, it will compare the difference between the latest commit of my current branch and the latest commit of master. So yeah, it's just you just need to know this, like, or look it up, like, yeah. In some cases, it checks the latest commit. In some cases, it checks the current version. It's a bit like there are certain historical reasons on why they did it this way, but it just is. Yeah. Um, okay. Now, let's say that you really like the changes that you were doing in the experiment and you want to push them to your main code. This is where we come into the concept of merging, which again is one of the next most important concepts of Git right after branching. Um, to merge two branches together, it's again conceptually it's very simple. You are in one branch and you're in branch A and you want to merge branch B onto branch A. That's how conceptually merging works. So if we want to merge the experiment branch on back onto master, we make sure we're currently in the master branch. So we can do this by checking running git branch. We see that we're in master, and then we just do git merge exp1. And yeah, it has added alice.txt, test1.txt, and yeah, made all the changes. And now if we go back to our file explorer, you can see we see test1 over here because we've merged it back onto the master branch. So whatever changes were in our experiment branch are now also in our master branch. Um, it's 4:50. Okay, any questions so far about everything we've covered? We have, yes, sorry for the delay. We have two topics remaining. One is merge conflicts. In this case, we had a completely separate file. So when we merged back into master branch, there were no conflicts. Everything worked perfectly well, perfectly fine. It was all happy. What if you and your friend make changes to the exact same line of code? How does Git, how should Git, okay, if let's say I make changes to one function and my friend makes changes to the exact same function, and we don't realize this, and let's say we try to merge his branch onto my branch, what should Git do? Like, which one should it take? Like, what do you think is the correct answer? Anyone? Like, how do you think Git should handle this conflict? The most recent one, that's one way to do it. Any other options? Yeah, and that is exactly what Git does. Git does not want to assume that one version is correct over another version, so it gives the choice to you. If at any point there's a conflict which Git does not like, it just stops the merge right there and tells you, hey, there's a merge conflict, resolve this before moving on. And it's a bit annoying, it's very complicated to resolve in a lot of cases, but for the most part, it ensures that, it ensures that you have control over your code and you're not accidentally deleting some important code. So, okay, we don't have time to go over the entire like how to resolve a merge conflict stuff, but it's all in the README. So if you guys want to, um, you know, like continue this workshop yourself, after merge conflicts, we also have like the GitHub part of it where, you know, how do you push to GitHub? How do you make a pull request? So let's say you're working on some open source library, you make a fork, make some changes onto your own repository, and then you really like what you've done with the repository, and you want to push those changes back to whatever place you forked it from. That's called making a pull request, where you can request for changes to be pulled from your repository onto the base repository. That's all covered in the README with all these instructions. So feel free to take a look. There is a lot of advanced stuff over here. So today we covered cloning a repository, committing files, checking Git status, checking differences, undoing changes, branching and merging. What we unfortunately weren't able to cover was fixing conflicts, Git push and Git pull, but um, it's all over here. If you want some advanced stuff, like if you want to challenge yourself even more, we have like a pull request branch, which there are some instructions on how to make pull requests and how to use Git for collaborative coding, which is really its most powerful aspect. And if you go to the revert branch, there's a lot of stuff about some advanced Git concepts, which even I don't remember. I always need to look this up. The revert method, the cherry pick method, so interactive rebase, so where if you merge a branch onto another branch, all of the commits from the second branch get put onto the first branch. By rebasing, merge sort of creates another commit. Like you in your Git log, you'll see a commit saying merge branch B onto A. By rebasing, instead of another commit, you get all the original commits just squashed onto your current branch. So it looks as if it was a very clean trail. You don't get any merge this, merge that, etc. So yeah, there's a lot of stuff you can do with Git. And um, any questions in the last 2 minutes? Great. Thank you guys for coming. Hope you learned something new. Uh, I should really pace this better next time. But yeah, if you have any questions, feel free to reach out to me. I'm happy to talk or help either later. If you have any questions, feel call me or we can tell. Yeah, thanks for coming, guys. Feel free to grab some more food on the way out and enjoy the rest of your day. You. Once again, if you have not filled the forms, please do it right now. Just scan this quickly, please. Yeah.